Hi guys, if you don't want to take the usual risk, you have to settle for the usual. In Reynolds transport theorem, we will be introduced to the term volume flow rate. The problem on this screen is about that. Maybe you can take a moment to read it. I suggest you don't skip this short animation. This is a pipe. There is an inlet and an outlet. If we look at the cross-sectional area of the inlet, it has a circular shape. Each point that passes through this inlet will have different velocities, both in magnitude and direction. The magnitude of the velocity of each point can be represented by a velocity field. V as a function of x, y, z, and t. The amount of volume per second that passes through the inlet cross-sectional area can be calculated through the equation. Q is equal to the double integral of the velocity field dot vector dA. This vector dA is the increment of the area of the cross-section passed by the fluid. This equation is very simple, we don't need time to memorize it. Let's go to the discussion sheet. Of course there is a velocity field written there. And the area that will be passed by the fluid is visible. Apparently the area is rectangular. This seems easy. Just write Q as the double integral of the velocity field dot vector dA. We already know the velocity field. So what about vector dA? dA is the area increment that makes up the cross-sectional area. For a rectangular area, the increment will be square. The lengths of the increments are dy and dz. Thus the area increment is dy dz. Vector dA is a vector that has a direction normal to the cross-sectional area. There are two normal directions of this cross-sectional area. Just choose the one that is in the direction of the positive x-axis. Since the direction is towards the positive x-axis, then vector dA is dy dz I hat. Now, we are going to do dot product. In dot product, the multiplication of unlike unit vectors will produce a value of 0. So this integral will change to the integral of 2y with respect to y and z. We just have to be careful about the limits of integration. The area starts from y equals 0 to y equals 5. From z equals 0 to z equals 4. This is correct. It seems easy. The integral of 2y with respect to y is y squared. Enter the limits of integration. The result is 25. Now, the integral of 25 with respect to z is 25z. Enter the limits of integration again. Q equals 100 cubic meters per second. This is the answer to this question. The speed of each particle passing through the area is different. The farther away from the center of coordinates, the faster the particle moves. But in each second, the volume of fluid passing through the area is 100 cubic meters. Happy learning, everyone.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.